Hello everyone, welcome to our class of business statistics. In the previous class, we discussed about collection of data, where we learned about primary and secondary sources of data, and we also learned about the different methods of collecting primary and secondary data. In today's lecture, we are going to cover about classification of data and tabulation of data. So we will learn uh, how to classify the data and then how to create a suitable relevant tables out of that classified data. So what are the key learnings for today? We will be learning about definition of classification and the basis for classification. And we will also learn how to build a frequency table where we will be learning how to create a class interval or how to create frequencies. And we will learn about like OGIFs and other things. And then we will learn how to construct a good table, do's and don'ts of creation of table. And lastly, we will learn about the difference between classification and tabulation. So what is classification? Classification is the process of arranging the data into different groups or classes based on the shared characteristics. So we are actually classifying similar item on the basis of their characteristics or their types in one class, and then and creating another class for the 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 data which is sharing other similar characteristics. And what we need to keep in mind while classifying the data, that classification should be done on the basis of some some characteristics or similarity. And what are the major benefit which we can do through classification? So through classification, we can condense our data, we can reduce the bulk data or disorganized data into more manageable size and manageable form, and we can have a better clarity in our data than the raw data. And obviously, if we classify the data and tabulate it, then it can be better used for analysis, and it can be more convenient to do analysis with that data. Four type of classifications. So how we can classify classify the data? We can classify the data on the basis of geographical location. For example, regional data, north zone, south zone, east zone, west zone. Or we can collect the data according to the cities, data collected from Delhi, from Mumbai, from Hyderabad, etc. So when the data is collected and categorized on the basis of location, then it is called geographical classification. Then data can also be classified on the basis of chronology. When we are classifying our data on the basis of time of occurrence, for example, the sales figure presented as quarters, first quarter sales, second quarter sales, third quarter sales, fourth quarter sales, or we are classifying our data on the basis of annual result, the data for 2005 to 6, 6 to 7, 7 to 8, so on and so forth. So when the basis for classification is time, then we can say it is a chronological data. Then third type of data is qualitative data. When we collect and classify the data on the basis of attribute or quality, right? Then this is called qualitative data. For example, these are uh, the fair, and these are the darker, or we can say these are the tall people and these are the long people, so on and so forth. Or this is the data for smokers, this is for non-smokers, tea lovers, pet lovers, etc. Quantitative data is the data which we classified on the basis of magnitude or into a numerical numbers. we are either creating a frequencies or we are creating a range from 0 to 10, 10 to 20, 20 to 30, so on and so forth. So we have different type of classification, sometimes on the basis of location, sometimes on the basis of time, sometimes on the basis of quality, and sometimes on the basis of class intervals. Some terms which will be repeatedly used during classification and tabulation are like class limits, which means the lowest and the highest values that is contained in the data set, right? Highest value is 100, lowest value is 10. And in this case, which is given there on your slide, is like 60 and 70. Class interval is the range of values which is defining one class group, say 10 to 20, 20 to 30. So this is the range, 10 to 20 is the range. Or I can say the first division holders have scored between 60 to 100. Second division from say 45 to 60. And third division say from 35 to say 45. This is actually a class interval where I'm creating a range for each uh, data unit or data group. Then a class width means the class size, which means upper limit minus lower limit. Then other term which is used is like class mark, which is nothing but midpoint. So if my range is say 10 and lower range is 10 and upper range is 20, then my class mark will be 15. 10 plus 20 divided by 2. And then frequency means number of observation falling in each class, in particular class. So if I say the frequency for the class range of say 30 to 40, 30 to 40 is 20, which means that uh, 20 observation are falling in this range of 30 to 40, which are more than 30 and less than 40. Okay, then moving ahead, then what is tabulation and why we need it? So tabulation is systematic arrangement of classified data into rows and columns. So it becomes more visual and more meaningful where you can uh, get the idea of the data at first glance. So you have created rows and columns and you are putting your classified data into rows and columns, right? So it is more structured and more summarized form of data. So what it do? Tabulation, it simplifies the complex data become easier. So it simplifies your data. It saves spaces. So I mean, you need not to write the data here and there. So it is now in more concise and more visible form. And it aids to comparison. Obviously, when it is tabulated, the comparison become much easier. And you can also detect errors because total and subtotals need to sometimes these need to confirm each other, and in that cases we can detect the error if it is there. So what are the essential of good table? Good table should contain a proper title and proper number for each title. It should be having the hard note for what the table is mean for. The captions means column heading, which means uh, what each column is describing. Then we have the stub row heading, which describe what each row represents. And then we have the body where actual numbers are given for each rows and column. And then we have the footnote and source note where the sources of data is mentioned. So if anybody is using the table, that person should be knowing that from where this data is obtained, should have a knowledge of the source of data. So now let us look into the rules of good tabulation. Every table should be clear. It is simple. It state all the unit and it state the unit, mention the units of the data. Whether data is data collected is in kgs, if it is of something, or is it in rupees, or is in centimeters, meters, depending on what type of data it is. So units should be mentioned clearly, and then rows and columns should align with each other logically. So by looking at any unit of the table, you can easily find out it belongs to which row and which column. Especially when you are doing the work with Excel, you would have seen that these rows and columns are very important when you are putting the functions. So it should align properly, because properly aligned data is more uh, visually uh, relevant and meaningful. So, and another important aspect of the good tabulation is like it provides total and subtotal of both rows and columns, so that person can find out what is the total strength. And if you want to find out the percentage of particular item in a table, you can easily find out by comparing it with the total. And lastly, good tabulation is reliable only when it is mentioned with the source. So if you are actually make it more reliable, then the source should be mentioned, so that any person who is using that table can cross check from where this data is obtained. Coming to the next part is frequency. So what is frequency? So if I have many numbers, say for example, I have like 2, 3, 7, 6, 5, 4, 2, 8, 6, 3, 4. So these are the numbers. Like if I'm using it as an individual or ungrouped data, then it's okay. But when I have large number of values, even say I have 100 such values, or say 1,000 such values, then actually dealing with this data becomes a little bit cumbersome or complex. So what I need to do, I need to create a frequency for this. So what I do, without repeating the numbers, if I say like what are the um, exclusive uh, or say mutually exclusive numbers are there. So I have 2, uh, 3. So I'm ignoring the repetitions and I'm writing each number once. I have 3, I have 4, I have 5, I have 6, I have 7, I have 8, right? So I have wrote down all the numbers once, and then I'm just checking out their repetitions. So 1, 1, 2, 3, 3 repetitions for what? 2. So I can write down its frequency. It means 2 is recurring 3 times. And then I'll take the frequency of 3. 3 is appearing only twice, so the frequency is 2. Then I can write the frequency for 4. So 4 is being repeated twice, so I can write 2. Then 5 is repeated 1, 2, 2 times, so the frequency is 2. Then 6 is repeated 1, 2, 2 times, so I'll write down 2. And then 7 is not at all mentioned. Oh, it is mentioned once, so I'll take 1. And then 8 is mentioned once, so I'll take the frequency 1. So what frequency did for my data? Actually, it classified the data in individual unit. So it is not taking the repeated data again and again. Rather, it it take it once and then mentioned it repetition through frequency. So if I say the frequency of 6 is 2, it means that 6 is repeated twice in my data. This is fair for discrete series. In discrete series, we can actually mention the data like this. So there is no values in decimals. But if I want to create a class interval, suppose if my data is like taking the values in decimals also, or if there are too many values still, so if then I need to write all the values at least once, so that will again become a cumbersome. So the other thing which I can do is I can create a class interval. So my data from say 1 to 5, 6 to 10, so and so forth. Or I can take like I can divide the classes. Say I can divide it like 1 to 3, 4 to 6, and 7 to 9, so and so forth. And then I can combine the frequencies of 1, 2, and 3, and then putting it in this range. So I have just created a class interval or range, and I'm putting all the values which are ranging, which is falling in this range of 1 and 3 in this range, and then the values which are falling in this range of 4 and 6, like 4, 5, 6, even 4.5, 5.5 in this range, and similarly all the values between 7 and 9 in the last range of 7 to 9. Okay, so actually frequency is helping me in creating a summary, and through this frequency I can I can show my data without repetitions. Okay, so what are the essential component of frequency? It must have a class or a referring unit, and then we are taking the essentials of frequency table. It must have a class, it must have a frequency, and then there is relative frequency and cumulative frequency. So what is relative frequency and what is cumulative frequency? So let us have a clarity about this with one example. Suppose I have 10 vehicles at my home. I have 3 cars, 4 motorbikes, cars, 4 motorbikes, and 2 bicycles for my kids, and 1 auto, right? So I have these 4 vehicles at my home, and I want to find out what is the weight of car in my total vehicle. So what I can do, total vehicles are 10. So weight of car is like 3 by 10 is 30%. So relative frequency of car in my vehicle is 30%. And relative frequency of motorbike is 40%. Similarly, relative value for bicycle is 20, and relative presence of auto rickshaw in my total vehicle is 10%. So this is actually called relative frequency, where we are taking the unit as a proportion of total, right? And then we have the cumulative frequency, where we can take the less than or more than values. For example, I've taken a frequency like the student who scored marks up to 40, then 40 to 60, 60 to 80, and 80 above. And the frequency is less than 40 is like say 10 students, less than 40 to 60 say 15 student, 60 to 80 say 12 student, 80 and above 8 student. So if I ask you how many students scored less than 60 who are unable to score first division, so what you can do, you just need to add this frequency. So the cumulative frequency in this case is how much? 10 plus 5 up to 60 is 25. Then cumulative frequency of less than 80 is 25 plus 12. This is 37. And cumulative frequency of less than 100 is 37 plus 8 is 45. So the AND value is also the total of the frequency. Okay. So this is called cumulative frequency. Cumulative frequency enables the straightforward comparisons across the group, whereas relative frequency serves as the foundation for histogram, polygon, etc. And frequency is helpful for us in identifying the model class, median class, and also to find out the mean. So frequency has its own importance. And usually we take the total of frequency as n. We are mentioning it, and sometimes we are also mentioning it using frequency. Whereas sometimes cumulative frequency is mentioned as or referred as CF. Moving to the next part, if you want to do it practically, because statistics is like a swimming pool. If you will not jump into it, you will not try yourself, you won't be able to learn how to swim. So you won't be able to learn how to find out find out the outcomes of the statistical problem until unless you tried it yourself. So let us try. So this is an example, and you have to create a frequency table out of it. So the values are 39, 42, 45, 52, 56, 58, 61, 64, 67, 69, 72, 73, 74, 77, 83, 85, 88, 91, 96, and there are many other possibilities. So these are few values. These values may be of for 1000 data, and my data will be for say 1 lakh observation. In that case, I'm not going to read all the numbers separately. Rather, I'll create a range and then put the values which are related to range um, uh, in their respective range. So in this case, what I do, I actually created a class interval because lowest value is 39 in this case. So I have taken the lowest value as 30 and the highest value as 100, right? And then I have created a class interval with the difference of 10. So class difference is 10, right? And then 30 to 40. So how many values are there from 30 to 40? 39 is the only value, and I look for other values which is in this range. So no other values more than 30, less than 40. So the frequency is 1. Then I look for all the values which are more than 40 and less than 50. So 1, 1, 2. So 2, the frequency is 2. Similarly, I have to take the values which are more than 50 and less than 60 in the next class. So I'll search the values and the frequency is 3. And then I have to take the values like from 60 to 70. So more than 60 and less than 70. 1, 2, 3, 4, 5, 5. So 5, the frequency is 5, so and so forth. So we have find out the number of repetitions of between the lower and the higher value of the range, and then I'm putting it in that particular range to and mentioned as the frequency of that particular range. So if I'm saying that the frequency of the range of 80 to 93, it means that there are three values which are more than 80 and less than 90, right? And if I want to take the cumulative frequency, then what I have to do, I just need to add up the value, add up the frequency. So 1 plus 2 is equal to 3, then 3 plus 3. So what I'm doing, this plus this is equal to this, then this plus this is equal to this, then this plus this is equal to this, so and so forth. So how I can use the cumulative frequency? I can use it like how many values are less than 80. So 15 values are less than 80. 15 observation are less than 80. How many observations are less than 60? 6 observations are less than 60. So this is useful when you are preparing the OGIFs, more than or less than curves, etc. Or you are even when you are handling with the distributions. We have already tried one question. Now it is up to you, and you have to try this question yourself. And remember that what you have to do, you have to create a class interval, pairs of each group, and then you need to create a frequency, and then you need to create a cumulative frequency in the fourth column. In the first column, you have to create a class interval, then frequency, and then in the third column, you can give the values for cumulative frequencies, which is nothing but you have to add up the frequency for each class or previous class. So all the previous classes, sorry, when you add up the frequency for all the previous classes. And I hope you can do it conveniently. There is no problem in it. And remember to give the title, and also to give the proper source if mentioned. If not mentioned, in this case, what you can do, you can give the clear title. For counts to useful comparison, we use tables and frequency table, and which is actually done after doing the proper classification. And we have already talked about relative class frequency, where we are mentioning the observation as a percentage of total. And we have already done tried one example of it, and you can think of other thing surrounding you where you can use the relative frequency. You can try it while buying the vegetables. So which vegetable is more in composition when you are handling with your balance sheet? You are finding out the weight of capital. So in that, or you are finding the weighted average cost of capital. There you can use the relative frequencies. And another is like cumulative frequency, when you are preparing ogives or less than curves. And frequency distribution is done through the creation of classes and then putting all the repeated value uh, in that class, which is, which is less than the lower limit of class and more than more than the lower limit of the class and less than the upper limit of the class, right? This is how we go with the numerical data. But if my data is categorical, then how you're going to deal with it? If my data is in category, it is not in number, then I can take the number, assign the numerical value to it. Though that numerical value is not carrying any mathematical property, then also it actually uh, I mean can be used for analysis. So for example, if I mentioned I have to mention male and female, and I want uh, to do analysis with male and female, then I can mention like male 1, female 2, true 1, false 0. In this way, we can assign the number, and we can assign the numerical number to the satisfaction level also, as you have seen while you are doing the rating from 1 to 10. So you are rating a movie or a play, then you are usually giving the rating from 1 to 10. Or you are giving, say, uh, the rating to the services of some hotel or hospitality industry, then also you are giving the rating from 1 to 10. In that case, you are actually giving numbers to the categorical data or categorical variable. Though that data can be used for analysis, but it cannot used as a uh, alternate for mathematical numbers, because it is not carrying the mathematical properties. Okay, then and this is the example. Another example which is given on the screen is like category, distinction, merit, pass, fail. You can mention it through assigning the numerical value to it. So what are the coding principle? If your data is categorical, code must be unique per category. No two categories should share the same code. Code should be consistent across all the data set. Binary coding are usually done as 0 to 1 or 1 to 2. Ordinal codes are reflecting the order or ranks. So ordinal codes should be properly in particular order, because it is actually a rank data which has to be in particular order. If you are going to change it, the meaning will change. So in the last part of today's lecture, we are going to draw the comparison between classification and tabulation, how these two are different. Whereas classification is sorting, tabulation is a display. So uh, if I differentiate both of these things from the meaning point of view, sorting the data into groups is classification. Arranging the classified data into rows and column is actually tabulation. When comes to like which is first and which is second, so classification is uh, is actually followed by tabulation, and tabulation is preceded with the classification. So you need to do classification of the data first, then you move to the tabulation. And output So what is the output of classification? Normally a set of classes or categories, whereas tabulation is actually a complete uh, summarized form, which is more readable and more visually say which is more useful for taking information at one glance. And the purpose is like for the classification of purpose is to bring similar item on the basis of their share, particular characteristics together. So we are actually bringing the similar item together. In tabulation, what we are doing, we are making the classified data more readable. So we are preparing and summarizing our data into more presentable and readable form. So what are the key learnings from today's lecture? So we learned about the classification, where we learned how to convert the raw data into grouped classes on the basis of geographical location, on the basis of magnitude, on the basis of time, quality, quantity, etc. And then we learned about frequency tables. We learned about the different type of frequencies. We learned about how to create frequencies, relative frequencies and cumulative frequencies. And then we learned about tabulation, and we learned do's and don'ts of tabulation. And lastly, we learned about how tabulation differs from classification. So this is all for today. In the next class, we will be covering about presentation of data. So we moved from the data to collection of data, then we moved to collection, we move to classification, tabulation, and then finally we are discussing the last part of it, which is presentation of data. Thank you for today. See you in the next class.